Welcome to Genique. So this is our next question. So this question is, see, for the circuit shown, the inductor current IL just before t is equals to 0. Just before t is equals to 0, the circuit is given. Okay, so in this circuit, one current source is given, and a resistance is given, and inductance is given. Okay, and here one switch is given here. So whenever the switch is given means we should come to notice that it is from the transients problem, right? So this question is from the transients. So what are these transients? Okay, so I don't want to go to the full details of the transients, but I will give some information regarding the transients, so it will be useful for solving the problems. Okay, so if you want to know the full details of the transient analysis, and you go to the crash course, and there the Pankaj Shukla sir has given tremendous information regarding the transients, and you can go to there and you can get the information from that. Okay, so but now I will give a brief information about the transients. Okay, so this is necessary for you, and it is sufficient for you to solve this kind of problems. Okay, so if you observe this, so what are these transients? So if you observe this figure, so here at t is equals to 0, the switch is closed, right? So here the switching operation takes place, right? Here the switching operation takes place at t is equals to 0, right? See, let us suppose this is the time axis. Let us suppose it is the time axis. Okay. Let here at t is equals to 0, the switching is occurred. Okay, the switching is occurred. See, observe this. Either it may be closed or opened. Okay, it may be closed or opened. If you observe this switch, at t is equals to 0, the switch is closed. Okay, why? It is in this direction. So you have to observe this arrow mark. Okay, the arrow mark is going in this direction. Right, at t is equals to 0, the switch is closing. Okay, suppose the arrow mark is in this direction. Suppose if the arrow mark is in this direction, at t is equals to 0, the switch is open. Right, so depending on the orientation, the state of the currents will be depending. Okay, the results also dependent on the switch orientation. So that's why you have to focus on the switch first. Okay, so whether the switch is opening or closing. Okay, either opening or closing, both are said as the switching operations only. Okay, right? So this is t is equals to 0. At this place, at this time, the switching is occurring. Okay, so now if you come to this point is called as t is equals to 0 plus. Immediately after the switching is called as the t is equals to 0 plus. Just before the switching is called as the t is equals to 0 minus. This is the point you have to identify. So there is no difference between 0 minus, 0, 0 plus in a continuous time, but it makes a sense in the transient analysis. Why means, so inductor and capacitor and resistor, these three are the passive elements. But in the inductor, see, if you observe the resistor, what happens? Whenever it absorbs the energy, at that instant of time, it will deliver the energy in the form of heat. Right? It will deliver the energy, means it will deliver the energy in the form of heat. Okay. But if you come to the inductor and capacitor, they are the storing elements. Okay. They are the storing element. So in the inductor and capacitor, so at that instant they cannot be able to deliver that energy, so as soon as the switching is changed. Okay, so you have to focus on this. Okay, so whenever there is a switching operation, they will not be in a position to change their state. So that is the meaning of this. Okay, so that is the point you have to understand. So because of that one, so there is some kind of oscillations will occur in the circuit. Okay, so these kind of oscillations are called as the transients, right? So after some time, what happens? After some time, the oscillations or the transients will be reduced and they go to steady state, right? So this is the thing you have to understand. At t is equals to 0, the switching is occurred. Okay, so this is called as the initial state. This is called as the initial state or initial time, initial state. Okay, so up to 5 time constants, okay, the transient state will be there. So this time is called as the transient time. This time is called as the transient time. Okay, and after 5 time constants, what happens? Up to infinity is called as the steady state. Up to infinity is called as steady state time, right? This is the point you have to observe. So whenever the switching occurred, from that switching time to up to 5 time constants, okay, we will know what is time constant exactly. Okay, so up to 5 time constant, the transient period will be there, and after 5 time constant, the steady state will be there. Okay, so the steady state is also called as the final state. This is also called as the final state, right? So final state means at t is equals to infinity. Okay, we consider after 5 tau, t is equals to 5 tau or greater than 5 tau, we consider after 5 tau as infinity only. Okay, but if you come to the left side, see, if you come to the left side, it is minus infinity. T is equals to minus infinity, right? Okay, so up from minus infinity to until the switching takes place, the circuit isn't stable, right? The circuit is not touched before that. Okay, so whenever the circuit is switching, okay, whenever the circuit is under switching, so then the changes starts. Okay, so then whenever the switching is occurred, then the changes will start. Okay, so from switching to the 5 time constant is called as the transient time. After 5 time constant is called as the steady state time, right? So this is the point. And from minus infinity to up to the switching, just before switching, okay, from minus infinity to just before switching is called as the again steady state, because it is not at all disturbed. The circuit is not at all disturbed until the switching. If you observe this, until the switching, the circuit is under steady state only. It is not at all disturbed. Happily the circuit is kept as it is. But whenever there is a switching occurs, either it may be closed or open, what happens? There is some disturbance in the circuit. Okay, that disturbance time from the switching to the disturbance time is called as the transient time, right? So this is the thing you have to observe. So from minus infinity to t is equals to 0 minus, this is also called as what? It is also called as steady state time. Okay, so this is also called as the final state. This is also called as, it is also considered as final, means from minus infinity to just before switching, it is also called as the steady state, means final state. Okay, but after 5 time constants, t greater than 5 time constant is also called as the final state. Okay, means steady state. But from the switching to 5 time constants is called as the transient time. Okay, so this is a very, very important. Just I am giving a brief information. I am not going into the details, but this much you should learn. Okay, so that means what? So from minus infinity to until the switching takes place, the circuit is said to be in the steady state, right? After 5 time constant, the circuit is said to be in steady state. But from 0 to 5 time constant, the circuit is said to be transient time. But if you observe this, at t is equals to 0, t is equals to 0 minus, t is equals to 0 plus, this is called as the initial time. This is called as the initial time. Okay, this is called as the initial time. From here to here, it is called as the transient time. From 5 time constants to infinity is called as the steady state time or final time. Okay, so from minus infinity to 0 is called as the steady state. Okay, the circuit is said to be in steady state. Okay, so this is the point you have to understand. And after that, now you might have known, so you have to focus on, so while you are dealing with the transients, you must focus on inductor current and capacitor voltages. Okay, inductor current and capacitor voltages, because the inductor, you have to write a note. Write a note. The note is the inductor current. The inductor current cannot be changed. Cannot be changed instantaneously. Okay? Cannot be changed instantaneously. Similarly, you have to write the capacitor voltage. The capacitor voltage cannot be changed instantaneously. Okay? So what is the meaning of this inductor current cannot be changed instantaneously? Capacitor voltage cannot be changed instantaneously means whenever the switching takes place, okay, so the current in the inductor after switching, just before switching is same, means continuous. So what is the meaning of this one is, okay, the inductor current cannot be changed instantaneously means, that means IL of 0 plus is equals to IL of 0 minus. This is the point you have to understand. Okay, so what is the meaning of this? The inductor current and capacitor voltage cannot be changed instantaneously. Right? We will see. And what is the capacitor voltage cannot be changed instantaneously? So VC of 0 plus is equals to VC of 0 minus. Okay, so this is the point you have to understand. Right? So this is the point you have to understand. So why means what is the inductor current and capacitor voltage? So you know very well what is the inductor current. Inductor current, if you observe this, what is the voltage across the inductor? The voltage across the inductor can be written as, the voltage across the inductor can be written as VL is equals to L into di by dl IL of t by dt. Right? So from this, what is IL of t? IL of t is equals to 1 by L integral minus infinity to t VL of t dt. So this is the inductor voltage and inductor current. So these are the expressions. You remember one thing. So if what is VL? VL is equals to L into di by dt. Right? IL of t is equals to integration of this one. Right? So this is very important. Minus infinity to t VL of t dt. It is an accumulation of the current. Okay. So if you observe this, so similarly we can write the capacitor voltage. So suppose, see, VL is equals to L into di by dt. Similarly, I will write the capacitor current is equals to C into dVc of t divided by dt. C dVc of t divided by dt. Okay. Similarly, Vc of t can be written as Vc of t. The voltage across the capacitor can be written as 1 by C integral minus infinity to t IC of t dt. IC of t dt. So these are the very, very important expressions. You have to remember this. So whenever there is a voltage across the inductor, you are writing L into di by dt. Similarly, in place of the voltage across the inductor, you have to write the current across the capacitor. This is equals to C into dVc by dt. So any of the way you can remember this. Okay. So this is the voltage across the inductor, current across the inductor. This is the current across the current to the capacitor. voltage across the inductor. Right? So these are the very, very important expressions you have to notice. Right? So these are very important. Now, if you observe this, what is IL of t? Suppose if I want to write IL of 0 plus. Okay? IL of 0 plus. Now what I am calculating? IL of 0 plus means the current through the inductor at t is equals to 0 plus, means immediately after the switching takes place. So now what happens? This will be equals to 1 by L into integral minus infinity to 0 plus, right? IL of t, right? So in place of t I am writing 0 plus here. So I have to write 0 plus there. Okay? So VL of t dt. And after integrating this we have to write these limits. Okay? So this is the thing. And this can be written as 1 by L into integral minus infinity to 0 minus, see, observe this, what I am calculating, the IL of 0 plus means 1 by L into minus infinity to 0 plus. That means we have to integrate the voltage across the inductor from minus infinity to 0 plus. From minus infinity to 0 plus, I have to integrate this. Now I am dividing this entire integral into two parts, from minus infinity to 0 minus and from 0 minus to 0 plus. Okay, so now I am dividing these two intervals into two. Okay, 1 by L into minus infinity 0 minus VL of t dt plus integral 0 minus to 0 plus VL of t dt. Right or not? So this is the thing you have to notice. So this is what? IL of 0 plus. If you observe this clearly, suppose if VL of t is a continuous function. If VL of t is a continuous function, now VL of 0 plus is equal to VL of 0 minus. Right? So this will become 0 if VL is continuous. Okay? VL is continuous, then this will be from 0 minus to 0 plus, it will be 0. That means if it is a continuous function, if there is no any abrupt change in the voltages, okay, if there is no abrupt change in the voltage between 0 minus to 0 plus, okay, what happens? 0 minus to 0 plus, what is the difference between these two? The difference between these two is 0 only. If you integrate this and you put the 0 minus 0 plus, you will be having a 0, right? So if you come to this, this is called as what? This is equals to 1 by L into integral minus infinity to 0 minus VL of t dt. I am naming this one as IL of 0 minus. This is the point you have to understand. So from this, IL of 0 plus is equals to IL of 0 minus. IL of 0 plus is equals to IL of 0 minus. So this is the point what we have written here. So that's why before the switching, just before the switching, just after the switching, okay, the inductor current remains same. The inductor current remains same. That is the point you have to notice this. Okay, the inductor will not be in a position to change its current even though the switching is changed. Okay, the switching is done. Okay, the switch position is changed. So that is the point you have to take care about this. So this is IL of 0 plus is equals to IL of 0 minus. Suppose what if there exists any impulse in the VL of t? What if there exists any impulse in the VL of t? Now you have to focus on this. Let us suppose if there is any impulse in the VL of t at t is equals to 0. At t is equals to 0. What happens? This will not be 0 now. This will not be 0. Now, what is impulse? VL of t can be written as delta of t. So, if I write VL of t is equals to delta of t or minus 0 minus to 0 plus integral 0 minus to 0 plus delta of t dt will be 1. Okay, here you have to write 1 by L also. Okay, right? Suppose if VL of t is delta of t, now what happens? IL of 0 plus is equals to 1 by L only, because this will be 0. Okay, so this is the point you have to understand. Suppose if VL has impulse at t is equals to 0 plus or t is equals to 0, now what happens? So IL of 0 plus is equals to IL of 0 minus. It will be there from minus infinity to 0 minus, it is continuous, but at t is equals to 0 there is an impulse. Okay, if t is equals to 0, if there is an impulse, in place of VL of t I am writing delta of t. Okay, I am writing delta of t. So 1 by L integral minus 0 minus to 0 plus delta of t dt is called as 1, right? So 1 into 1 by L. Okay, so plus 1 by L will be there. Plus 1 by L will be there. This is only for the impulse existing in the voltage of the inductor. Okay, this is only for the, if any impulse existing in the voltage of the inductor. This is the point. You have to take care about this. Okay, suppose if voltage across the inductor itself, suppose if the voltage across the inductor itself is the impulse function. So what is the meaning of this? Suppose if the voltage across the inductor itself is the impulse, now what happens? If VL of t is equals to delta of t, if the voltage across the inductor itself is the impulse function, now what is IL of 0 plus? Now what is IL of 0 plus? IL of 0 plus is equals to, what happens? IL of 0 minus, the impulse will be existing at t is equals to 0, right? T is equals to 0. So before that t is equals to 0, what happens? Before t is equals to 0, the current is 0, right? Before this, what is VL of t? VL of t is existing. VL of t is del of t. What happens? From 0 minus to from minus infinity to 0 minus, it will be 0. Only this will be existing. So IL of 0 plus will be equals to 1 by L. This is also very important. These are the two special cases of this inductor current. Okay, mostly in general the inductor current cannot be changed instantaneously until the voltage across the inductor is continuous function. Okay, so it is a very important thing you have to understand. IL of 0 plus is equals to IL of 0 minus, and in this also there is one condition. If there exist any impulses in the voltage, now what happens? IL of 0 plus is equals to IL of 0 minus plus 1 by L. Suppose if you take this one as IL of, if there exists any voltage, if there exists any impulse at the t is equals to 0, right? So 1 by L is added to this. Suppose if the voltage across the inductor is itself is the delta of t, now this will, IL of 0 minus will become 0, IL of 0 minus will become 0. Now it will be IL of 0 plus will be equals to 1 by L only. IL of 0 plus will be equals to 1 by L, because this will be area under the impulse function is 1, right? So this is a very important phenomena, right? Very important. So this is a very important thing. So the inductor current, you should remember that the inductor current cannot be changed instantaneously. Okay, IL of 0 minus is equals to IL of 0 plus. The inductor current just before switching is equals to just after the switching. Similarly, and before going to this, suppose what will be the energy stored in the inductor? Okay, so for this case, what is the energy stored in the inductor? Energy stored in the inductor E of 0 plus is equals to half L I square, I of 0 plus square. This is the point you have to remember. So this will be is equals to how much? This will be is equals to 1 by 2L. This is for the impulse input. Suppose if there is any impulse across the inductor, then this will be the energy stored in the inductor, right? This is one case, and this question is asked in the public sector unit exams also. So you have to remember that it is for the impulse as the voltage across the inductor. Okay, So, but this is very important. Okay. Similarly, if you take the capacitor voltage, okay, suppose if you take the capacitor voltage now, if you take the capacitor voltage, so what is Vc of t? The Vc of t can be equals to Vc of t is equals to 1 by c integral minus infinity to t. I am writing Vc of 0 plus. I am writing Vc of 0 plus. Vc of 0 plus means here also I have to write 0 plus. IL of IC of t into dt. Right? So I am writing this 1 by c integral minus infinity to 0 minus. I am again splitting the intervals IC of t dt plus 1 by c integral 0 minus to 0 plus 0 minus to 0 plus IC of t dt. This is the point you have to understand. So Vc of 0 plus is this one, right? Right? Suppose if IC of t is a continuous function, then this will be 0. This integration will be 0 if IC of t is continuous. Right? So from this, what we can write? So Vc of 0 plus is equals to Vc of 0 minus, because 1 by c integral minus infinity to 0 minus IC of t dt is called as the Vc of 0 minus. So this is Vc of 0 minus. Right? So Vc of 0 plus is equals to Vc of 0 minus. What is the meaning of this? The capacitor across the voltage across the capacitor, okay, before switching, after the switching, just before the switching and just after the switching will be same. The meaning of this one is the capacitor voltage cannot be changed instantaneously. So at that instant of the switching, it cannot be changed. It will remain same. That is the meaning. You should remember that. Okay. So the voltage across the capacitor cannot be changed instantaneously. Okay. It will not change its state. It will be having the same voltage just before and just after the switching. Okay. Suppose if there exists any impulses, okay, if right here, if IC of t has impulse at t is equals to 0, what happens? Now Vc of 0 plus is equals to Vc of 0 minus plus 1 by c. Okay, Vc of 0 plus is equals to Vc of 0 plus 1 by c. Right? If there exists any impulse at the t is equals to 0. Similarly, what will be the, suppose if IC of t itself is the impulse function, okay, IC of t, the current through the capacitor itself is the impulse function. Now what happens? If IC of t is equals to delta of t, now what happens? This will be equals to, this implies Vc of 0 plus is equals to, it will be 0 because this will be 0, okay. This one only will be existing 1 by c integral 0 minus to 0 plus IC of t dt. IC of t can be written as delta of t. So this will be 1. So 1 by c. Right? So from this, what is the energy stored in the capacitor at t is equals to 0 plus? Just immediately after the switching. So up to that time, what is the energy stored in the capacitor? Half C V C of 0 plus square. So this will be equals to half C Vc of 0. What is Vc of 0 plus? Vc of 0 plus is 1 by c square. So this will be 1 by 2c. This is the energy stored in the capacitor at t is equals to 0 plus. So this is the theory you should know. Mostly they will be asking in these areas only. So here you have to remember up to this, the 4 expressions, okay, and here IL of 0 plus and IL of 0 minus, IL of 0 plus is equals to IL of 0 minus, Vc of 0 plus is equals to Vc of 0 minus. So these are the things you should remember, okay. Next,